In the silent hum of the modern world, where billions of calculations flash through circuits every second and unseen instructions quietly determine what we watch, where we drive, what we buy, and how our entire digital reality functions, there lies a hidden truth almost no one ever thinks about. All of it began with one man. A scholar seated not in a futuristic lab, but in a candle-lit chamber more than 12 centuries ago. As satellites orbit above us, as artificial intelligence predicts our movements, as computers solve problems in nanoseconds, we rarely stop to ask who created the very concept that makes all of this possible. Who first imagined a step-by-step procedure, a universal method that could solve problems with certainty and precision? The answer is found not in the age of computers, but in the heart of the 9th century, in a world of parchment and ink, where the spark of mathematical logic was first transformed into a living system, an invention humanity would one day call the algorithm. To understand this story, we must travel back to a golden age unlike any other, a time when knowledge was not scattered but gathered, preserved, and elevated, a time when the greatest minds from 3 continents met under one roof. In the thriving capital of Baghdad, inside the legendary House of Wisdom, the air itself felt electric with ideas. Scrolls arrived from Persia, India, Greece, Rome, China, brought by caravans, translated by scholars, debated in vast halls lined with books and astronomical instruments. Here, surrounded by the finest mathematics, astronomy, and philosophy of the ancient world, a young Persian scholar named Muhammad ibn Musa Al-Khwarizmi stepped into a new intellectual universe. He had access to every major text of antiquity, every number system known to mankind, every method of calculation ever attempted. But he did not merely study these ideas, he reorganized them, reshaped them, and forged something entirely new. At this moment in history, mathematics was a scattered field. The Greeks excelled in geometry but struggled with practical arithmetic. Indian mathematicians had created powerful numeral systems, but lacked a universal method to process equations. Merchants, navigators, and astronomers across the world still relied on approximate techniques, trial and error, or methods tied to specific cases. There was no unified approach, no clear logic, no guaranteed path from question to answer. And in this intellectual chaos, Al-Khwarizmi saw a pattern waiting to be discovered. In the dusty silence of the House of Wisdom, he began crafting a radical idea, a set of precise rules, clear, repeatable, universal, a system that could take any problem, break it into steps, and reach a solution with certainty. He was not just doing mathematics, he was inventing a new way of thinking. This was the birth of the algorithm, a creation so simple in spirit, yet so powerful in structure, that it became the backbone of every mathematical process that followed. Yet, Al-Khwarizmi could not have imagined the scale of his legacy. He could not have foreseen that his methods would one day run every computer, guide every spacecraft, encrypt every transaction, and shape the global digital age. But that is the extraordinary paradox of history. Its greatest revolutions often come from places no one expects. And in that ancient room, illuminated only by the soft flicker of oil lamps, a man writing with ink and reed pen laid the foundation for the future of humanity. For centuries before the rise of Muhammad ibn Musa Al-Khwarizmi, the world of mathematics was a fragmented landscape of ancient traditions that often contradicted one another. Greek geometry, Babylonian arithmetic, Indian numerals, and Egyptian measurement methods existed as separate islands of knowledge. Some were elegant, others practical, but none formed a unified system capable of solving the increasingly complex problems faced by astronomers, merchants, architects, and scholars across the Islamic world. As the Abbasid Caliphate expanded, ruling a vast region filled with diverse cultures, languages, and scholarly traditions, the need for a universal mathematical language became urgent. Astronomy required accurate calculations to determine prayer times, and the direction of Mecca geography demanded improved measurements of distance and latitude. Trade called for systematic bookkeeping, while architecture and engineering needed reliable methods for land division, inheritance distribution, and taxation. Into this atmosphere of intellectual hunger stepped a young scholar from Khwarazm, a region in modern-day Uzbekistan, who would eventually redefine the concept of mathematical problem-solving itself. Al-Khwarizmi arrived in Baghdad at a time when the city was becoming the world's scientific capital. Under the leadership of Caliph al-Mun, the famed House of Wisdom gathered translations of Greek, Persian, Sanskrit, and Syriac texts, creating an unprecedented multi-civilizational knowledge base. Scholars in mathematics, astronomy, medicine, and philosophy worked side by side, exchanging ideas that had never before met. Among them, Al-Khwarizmi found both inspiration and an intellectual home. His early work involved developing astronomical tables and geographical measurements, but his most revolutionary contribution came when he began thinking about numbers in a new way, not simply as quantities to be manipulated, but as symbols within a logical framework that could be used to generalize solutions. Before him, mathematical methods were often tied to specific problems. Each new scenario demanded a unique approach. Al-Khwarizmi changed this. He sought universal rule steps that, if followed correctly, would solve entire categories of problems regardless of the numbers involved. This shift from isolated calculations to systematic procedures laid the foundation for what we now call algorithms. Long before computers existed, he imagined mathematics as a sequence of precise instructions. In doing so, he transformed an ancient discipline into a powerful tool capable of shaping science, engineering, and technology for centuries to come. When Al-Khwarizmi began his work in the early 9th century, Baghdad's House of Wisdom was more than a library, it was a living engine of knowledge. Scholars gathered manuscripts from the far reaches of the known world, translating works from Greece, Persia, India, and beyond. It was within this intellectual melting pot that Al-Khwarizmi found the raw ingredients that would shape his revolutionary thinking. He studied Greek geometry, but he also examined Indian numerals, which introduced a place value system far more powerful than Roman numerals. He absorbed Babylonian astronomical methods and Persian administrative mathematics. With each tradition offering strengths and limitations, he recognized the need for a structure that could unify them into a coherent, practical system. Al-Khwarizmi's brilliance lay in his ability to synthesize. Rather than choosing one mathematical heritage over another, he integrated them. His landmark book, Algebra wal Muqbala, provided the world with something unprecedented, a methodical approach to solving equations that did not rely on geometric diagrams or memorized tricks. Instead, he presented rules-clear, step-by-step instructions for reducing and balancing equations. The word algebra, meaning restoration or completion, referred to the process of moving terms to eliminate negative quantities. Muqbala, meaning comparison, described simplifying and balancing expressions. These processes created a standardized method for transforming any valid equation into a solvable form. This new way of thinking marked a turning point in mathematical history. Al-Khwarizmi was not merely solving equations. He was inventing the discipline of algebra. His method freed mathematics from concrete numbers and shifted the focus to relationships between variables. This abstraction made it possible to generalize solutions and apply them to countless real-world problems. In astronomy, his techniques improved calculations for planetary motion. In commerce, they aided in dividing inheritances and managing taxation. In engineering, they offered tools for measuring land and designing structures. And yet, Al-Khwarizmi pushed even further. He recognized that mathematical problem-solving needed a universal, repeatable structure. His procedural steps, outlined with remarkable clarity, became the blueprint for algorithms. In a world with no computers, he created the conceptual skeleton upon which all modern computation would eventually be built. The House of Wisdom gave him access to knowledge. Al-Khwarizmi gave that knowledge a language. Al-Khwarizmi's Algebra wal Muqbala stands today as one of the most influential mathematical texts ever written. Composed around 820 CE, it redefined mathematics by presenting methods that applied universally, not just to specific examples. Instead of relying on geometric interpretations or narrative problem descriptions, Al-Khwarizmi established algebra as a self-contained system of rules. The book dealt with linear and quadratic equations, breaking them into 6 standard forms. This classification allowed mathematicians to approach problems systematically rather than improvisationally. He provided clear instructions for how to manipulate and reduce each type of equation, making the process accessible even to those unfamiliar with advanced mathematics. His explanations were rooted in practicality. He connected mathematical procedures to real-world applications, demonstrating how algebra could solve inheritance disputes, calculate dowries, determine building dimensions, and allocate land. This utilitarian approach ensured that his work spread rapidly among scholars, administrators, and merchants. Unlike earlier traditions that were often abstract or philosophical, Al-Khwarizmi's algebra was a working Tilla method that anyone could learn and apply. One of the most revolutionary aspects of the text was its emphasis on procedural thinking. Instead of offering individual solutions, Al-Khwarizmi provided step-by-step methods. These procedures could be followed repeatedly to solve entire categories of problems. This was the essence of algorithmic thinking. An algorithm, in its simplest form, is a set of instructions designed to achieve a specific result. Al-Khwarizmi's rules were exactly that: instructions that could be executed reliably to transform and solve equations. Whether dealing with numbers or variables, the steps remained consistent. The significance of this approach cannot be overstated. It laid the groundwork for the systematic thinking that underlies modern mathematics and computer science. Just as an algorithm in computing today performs operations in a predefined sequence, Al-Khwarizmi's algebra required problems to be approached through ordered logical steps. His work bridged the gap between ancient arithmetic and the abstract reasoning that would shape future scientific advancements. When his book was translated into Latin in the 12th century, it became the foundation of European mathematics. The Latinized title, Algebra, gave the discipline its name. His own name, Al-Khwarizmi, evolved into algorithmy, from which the modern word algorithm is derived. Through this text, he crafted a legacy that continues to influence every equation solved, every computer program executed, and every mathematical problem approached with systematic logic. Long before machines could process data or perform automated calculations, Al-Khwarizmi envisioned a world where mathematical problems could be solved through systematic procedures. His approach to algebraiking problems into general forms and applying consistent steps mirrored the logic that governs modern algorithms. In Kitab al-Jabr wal-Muqbala, he described how to isolate variables, eliminate negatives, and balance equations. But more importantly, he showed how these processes could be applied universally. This abstraction, turning specific situations into general rules, marked a revolutionary shift in intellectual history. Al-Khwarizmi's algorithmic thinking did not stop with algebra. In his works on arithmetic, such as On the Calculation with Hindu Numerals, he provided step-by-step methods for performing addition, subtraction, multiplication, and division using the decimal system. His explanations were procedural: follow this step, then that step, and you will always reach the correct result. These instructions replaced older systems that relied heavily on memorization or geometric reasoning. Instead, he offered a repeatable structure accessible to anyone trained in the method. This emphasis on procedure spread quickly because of its practicality. Astronomers used his algorithms to compute celestial movements more efficiently. Geographers applied them to map distances and coordinates. Administrators used them to manage taxation and inheritance. Merchants relied on them for bookkeeping and currency conversion. The more widespread his methods became, the more they shaped the intellectual habits of scholars across the Islamic world. When his works reached Europe, translated into Latin during the 12th century Renaissance, they profoundly impacted Western mathematics. The term algorithm, derived from the Latinized form of his name, referred to the new method of calculation that used Hindu-Arabic numerals and procedural steps. Over time, algorithm evolved into the modern word algorithm. Today, an algorithm describes any set of instructions designed to perform a task precisely, the type of reasoning Al-Khwarizmi introduced. Without realizing it, Al-Khwarizmi had laid the conceptual foundation for the logic used in all computer programs. His insistence on clear, repeatable steps is the core principle behind programming, artificial intelligence, encryption, and data processing. His contributions were not limited to solving equations. They reshaped human thought. Instead of treating mathematics as a collection of isolated techniques, he turned it into a structured discipline governed by universal laws. In doing so, he built the mental architecture upon which the digital world would eventually rest. The brilliance of Al-Khwarizmi's work lies not only in its theoretical innovation but also in its practical application. The medieval world was filled with problems that demanded systematic solutions. Trade routes stretched from Spain to China, requiring accurate methods for currency conversion, taxation, and commodity pricing. The expansion of the Islamic Empire created complex inheritance laws that required precise calculations. Astronomers needed efficient procedures to determine prayer times, lunar phases, and the Qibla, the direction of Mecca, from any point on Earth. Each of these tasks required methods that were dependable, consistent, and adaptable to different situations. Before Al-Khwarizmi, such problems were often addressed using ad hoc techniques passed down through tradition. These methods worked but lacked standardization. Different regions used different rules, leading to confusion and error. Al-Khwarizmi eliminated this chaos by introducing clear, universal procedures. His arithmetic algorithms made calculations faster and more reliable. His algebraic methods provided structured solutions to problems involving unknown values. His astronomical tables simplified complex computations into manageable steps. For the first time, a mathematical framework existed that could be taught, replicated, and trusted. Consider inheritance calculations, a significant issue in Islamic law. The distribution of wealth among family members required precise mathematical ratios. Al-Khwarizmi's algebra allowed scholars to translate legal rules into equations that could be solved logically. No longer did judges rely solely on precedent or estimation. They followed a systematic procedure that ensured fairness and accuracy. Similarly, surveyors used his geometric methods to measure land and determine boundaries, essential for agriculture and taxation. His algorithms also transformed commerce. Merchants calculating profit margins, exchange rates, or installment payments now had reliable tools. The adoption of Hindu-Arabic numerals, popularized through his work, made arithmetic far more efficient than with Roman numerals. This improvement alone accelerated economic activity across continents. In astronomy, his contributions were equally transformative. His Zij tables organized astronomical data into an easy-to-use format, allowing scholars to compute celestial positions quickly. These tables became standard references from the Middle East to Spain. Al-Khwarizmi provided not just solutions, but stability. His methods reduced the uncertainty and inconsistency that had characterized earlier mathematical practices. By bringing order to chaos, he demonstrated the true power of algorithms, the ability to solve real-world problems with precision, reliability, and clarity. Al-Khwarizmi's influence expanded far beyond the borders of the Islamic world. After his works were translated into Latin in the 12th century, European scholars encountered a mathematical system unlike anything they had seen before. Roman numerals, with their rigid structure and lack of positional value, were inadequate for advanced calculations. Al-Khwarizmi's presentation of the Hindu-Arabic numeral system offered a revolutionary alternative. His procedural methods for arithmetic, explained with clarity and step-by-step logic, became the foundation for what Europeans called algorithm. This method spread rapidly across universities and monasteries, transforming mathematical education. His algebra also left a profound impact. European mathematicians such as Fibonacci studied his works, adapting and expanding them. Al-Khwarizmi's classification of equations became the starting point for scholars who later developed symbolic algebra. His influence can be seen in the evolution from rhetorical mathematics to the symbolic notation used today. Without his systematic approach, the mathematical revolution of the Renaissance might have unfolded very differently. But his legacy extended beyond arithmetic and algebra. His contributions to geography included revising Ptolemy's world map and producing coordinates based on new measurements. His astronomical tables influenced European astronomy for centuries, shaping the work of scholars even into the early modern period. In many ways, he helped reconnect Europe to a scientific tradition that had been partially lost after the fall of the Western Roman Empire. As the Renaissance progressed, the algorithmic mindset he introduced clear procedures, universal rules, logical sequencing became woven into the fabric of scientific thinking. Whether in navigation, finance, architecture, or engineering, structured problem-solving replaced older trial-and-error methods. His influence helped shape the intellectual foundations of modern science. The adoption of his name into European vocabulary is itself a testament to his impact. Algorithmy became associated with calculation, eventually evolving into the modern word algorithm. This linguistic transformation reflects the deeper conceptual shift he created, from mathematics as manual calculation to mathematics as structured reasoning. By the time Europe entered the scientific revolution, Al-Khwarizmi's ideas had become so deeply embedded in mathematical practice that few realized their origin. His legacy traveled silently through centuries, shaping education, discovery, and innovation. He had become one of history's most influential but least recognized architects of knowledge. Although Al-Khwarizmi lived more than a millennium before the electronic computer, his intellectual fingerprints are embedded in every digital device used today. The fundamental concept behind programming performing operations through a sequence of logical steps directly reflects the algorithmic structure he introduced. Each line of code written by a programmer follows the same principle he established: define the problem, break it into steps, and execute the steps in the correct order. In a very real sense, modern computation is the expansion of Al-Khwarizmi's vision into the realm of technology. The decimal system he explained became the basis for global mathematics. The algorithms he introduced for arithmetic evolved into machine operations for calculators and computers. His algebraic methods laid the groundwork for symbolic logic, which would later shape Boolean algebra and the architecture of digital circuits. Every search engine, encryption protocol, data sorting function, or artificial intelligence model depends on algorithm-structured procedures that trace their conceptual ancestry to his work. In cryptography, for example, prime number algorithms protect financial transactions, messages, and digital identities. These principles draw from the same algorithmic mindset Al-Khwarizmi pioneered. Machine learning models rely on iterative algorithms, precise sequences of operations designed to optimize outcomes. Even routing systems used in navigation apps operate through algorithmic logic. His influence extends beyond the technical. The educational shift toward teaching students how to think algorithmically reflects his original vision of problem-solving through structured reasoning. In science and engineering, his procedural approach is a cornerstone of the scientific method: define, analyze, compute, and verify. Without such structure, modern innovation would be impossible. What makes Al-Khwarizmi's legacy extraordinary is its universality. His ideas transcend time, culture, and technology. He did not merely introduce new equations. He introduced a new way of thinking. He moved mathematics from concrete numbers to abstract relationships, from isolated solutions to universal methods. His insights enabled humanity to create machines capable of processing vast amounts of information and solving problems at unimaginable speed. Every smartphone operation, every algorithmic decision, every digital calculation is, in essence, a continuation of the intellectual revolution he began. Al-Khwarizmi built the conceptual foundation for the digital age long before electricity, silicon chips, or computers existed. He showed that logic could be encoded, that procedures could be universal, and that knowledge could be systematized. In doing so, he became not only the father of algebra, but the ancestor of modern computing. For more than 1,000 years, the name Muhammad ibn Musa Al-Khwarizmi has echoed quietly through history, not with the thunder of conquerors or the majesty of kings, but with the enduring brilliance of ideas that never fade. His work did not carve empires into the earth. It carved pathways into the human mind. It reshaped how civilizations calculated, measured, traded, studied the heavens, built their cities, and organized their knowledge. From the quiet halls of the House of Wisdom to the algorithms that guide spacecraft, diagnose diseases, secure digital communication, and power every computer on the planet, a single thread leads back to one scholar working under the soft lamps of 9th century Baghdad. What Al-Khwarizmi created was more than mathematics. He gave humanity a new way of thinking, a structured, logical, procedural method to approach the unknown. He took the scattered fragments of ancient arithmetic and shaped them into a universal language. He transformed problem-solving from an art into a science. And in doing so, he laid the intellectual foundations for algebra, algorithms, and ultimately the entire digital age. Every time a search engine suggests an answer, every time code executes a function, every time a machine follows a clear sequence of steps, it echoes the spirit of the method he first defined. And yet, the beauty of his legacy is not only in its technological impact, but in its timeless simplicity. Al-Khwarizmi believed that knowledge should be accessible, useful, and shared. His writings spoke to merchants as easily as they spoke to scholars. They guided architects, astronomers, surveyors, and students. They crossed deserts, seas, languages, and centuries. They survived the fall of dynasties, the collapse of institutions, and the loss of the very library where they were born. His ideas outlived the walls that once protected them. As the world steps deeper into an age shaped by artificial intelligence, quantum computing, and digital networks, the essence of Al-Khwarizmi's vision remains more relevant than ever. Clarity in thinking, precision in method, and the belief that problems, no matter how complex, can be solved through logic, structure, and imagination. His legacy is a reminder that progress begins not with machines, but with the human mind daring to ask better questions. In the end, Al-Khwarizmi's story is the story of how one scholar unlocked a new dimension of human capability. Not by force, but by thought. Not through conquest, but through understanding. And as long as algorithms continue to shape our world, his influence will continue to live quietly, powerfully, and endlessly, guiding the future he helped create more than a millennium ago.